Wanted to share an interesting principle that shows the difference between radiative energy losses and convective energy losses. So when you're dealing with energy losses as far as thermal temperature goes within a greenhouse, up here in the Rocky Mountains of Idaho, your primary mechanism for energy transfer is radiative. We got down to 33 degrees Fahrenheit on Monday morning, and it killed this squash plant. But if you look behind me, these particular leaves are not frozen. This particular vent acts as a radiative heat shield effectively at our elevation, which is over a mile high, and we're surrounded by very high mountains. What happens is the energy transfer to the atmosphere has very little impedance because of the climate here. Those mountains actually create a frost bowl, and we have a very dry atmosphere here that promotes energy transfer through radiation. The peaks are about 12,000 feet high. That really creates an interesting geography. With the polycarbonate on top, it acts as a heat shield against radiative losses to the atmosphere. It's the ones that are away from the heat shield that were damaged by the evening frost. Keep in mind, the air temperature was only 33 degrees Fahrenheit. This principle is also shown here where the vine for this squash was outside of the boundary of the radiation shield, this polycarbonate that acts as a vent, whereas the leaves that were under it fared very well. This principle demonstrates why, if you have a single layer of polyethylene on a high tunnel at high elevations with dry climates like we have here in Idaho, you're actually going to freeze inside your greenhouse pretty close to when you freeze outside. And that's why for climates like ours, it's important to use a multi-wall polycarbonate or even an inflated multi-wall polyethylene. My observation is that there's two ways in greenhouse design to approach things. If you actually just cover things horizontally, even with open sides, you're still going to extend your growing season if that material you're using has some insulative value. It's really not a big deal at lower elevations and wetter climates because the atmosphere actually acts as insulation, protecting from that radiative losses. But here at the tops of the mountains and the Rockies, you need to be a little bit more sly in terms of how you design your greenhouse. I use a 4-layer polycarbonate. This happens to be an 8mm thickness, but there's actually 3 separate air pockets because there's 4 independent layers in this extruded polycarbonate. That gives my greenhouse film, or the glazing on the sides of the greenhouse, an effective R value of about 2.22, which really gives some amazing protective balance. I don't worry about shutting my vents until it's about 26 degrees Fahrenheit outside. I've noticed that about 26 degrees Fahrenheit is the threshold that greenhouses, or at least my greenhouses, can survive. So an air temperature of 26 degrees Fahrenheit is right on the cusp of when I'm going to lose my greenhouse. So by leaving my vents open until then, I don't have any problems with frost damage inside. These particular high tunnels are a European style, and generally speaking, they're meant for a moderate European type climate, the kind of climate you're going to see on the West Coast, like Oregon, Washington, or even on the East Coast, such as Boston. My observation, even with this specialized 4-layer glazing, is that you can only get to about 9 degrees outside temperature before you freeze inside. So glazing is a fundamental feature of your greenhouse design, but the other feature that you have to consider is your architecture. We're at a higher northern latitude, and what that results in is a very low angle for sunlight at the end of December. Because there's small surface area in comparison with the floor area, you have less area that you lose energy at overnight in the wintertime. Yeah, I appreciate you taking the time to watch this video, and I hope it was helpful. Have a good day.